just mentioned, I was affiliated with Iowa State University. I use the past tense. I no longer work there. I'm retired as of last year. I worked at Iowa State for 23 years and retired from the agronomy department. But I've been involved with a number of farm groups since my retirement. I've continued with Practical Farmers of Iowa, and I work with our food co-op here in Ames. I also am still involved in doing science, editing scientific journals, and I like to keep my hand in. So Jess reached out and asked me if I could provide some information concerning carbon dioxide pipelines, specifically with regard to how they affect soils, crops, and greenhouse gas emissions. So I'd like to share about a dozen slides with you and then open it up for any questions you might have. And I'm going to draw heavily on work that was done by colleagues of mine at Iowa State University when the Dakota Access Pipeline came through. And the Dakota Access Pipeline went through Boone and Story counties, close to the Iowa State University agronomy farm main headquarters. And a number of agricultural engineers and some of my agronomy and soil science colleagues initiated studies on how the construction of this pipeline affected soil properties and crop yields. And I think it's a good illustration of what pipelines are likely to do to farmland in Iowa, because the construction characteristics are going to be quite similar if they put through the carbon dioxide pipelines. So this work was initiated when the pipeline construction in central Iowa was occurring in 2016. And the researchers went out and looked at what was occurring in terms of, how does this take place and over what proportion of a field that would be used for corn and soybean production might we expect some of these impacts. And they published all this work in a variety of scientific journals. You'll see the name of the lead investigator here, Takesti, published one paper in Soil Use and Management. And what they show here is that the construction of these pipelines for either oil or carbon dioxide requires the use of heavy equipment. What happens is they move the topsoil from about the first foot out of the construction zone so that they don't damage the physical structure of that. But the subsoil is left to bear the weight of this construction equipment, which has high axle loads and is capable of compressing the soil to a considerable degree. And as all of you who are landowners and farmers are aware, the pore space in soil, the air space that exists between soil particles, is really important for gas exchange for crop roots and the ability of roots to penetrate deeper into the soil profile to access nutrients and water. So all this is connected, right? The pipeline construction occurs, soil is moved, soil is disturbed in some way, and soil compaction takes place. And that's likely to have an effect on crop performance. So they conducted this study. A number of people were involved from both the crop and the soil angles, and they got some results that I think are very worthwhile to consider if you're a landowner or a farmer. So this graph takes a minute to explain, but I think it'll be intuitive. On the left side of the graph, you have soil depth in centimeters, and 1 meter or 100 centimeters is about 39 inches. So we go from the soil surface at 0 at the top of that graph down to 140 centimeters, which is about 48 inches, 50 inches deep. On the right side, oh, excuse me, across the top of the graph is what they call bulk density. And bulk density is a measure of how much airspace there is in the soil. The higher that bulk density number is, the more compact the soil is, and the less airspace, the less pore space it has. So as the number goes up, the soil is more and more impenetrable for crop roots and contains less space for gas exchange, which is really important for root health. So the blue line, the red line, and the yellow line all represent the places where the trench for the pipe was put in, Z1, which is in yellow. Heavy traffic occurred, which is in red, Z2, or lighter traffic occurred a little farther away from the pipeline. And you can see that the control areas that didn't have any construction equipment, the green line, CS, which is control south, and CN, which is control north, have much lower bulk densities, particularly at 20 centimeters, which is at 8-inch depth, down to about 100 centimeters, which is about 40-inch depth. And those blue, red, and yellow lines that are to the right of the green lines indicate that the soil was seriously compacted below the topsoil layer. And remember, I said that they moved the topsoil out of the way when they ran the machinery there. Additionally, in this study, the subsoil area was subjected to deep tillage implements. They ran rippers through it. So this compaction that you're seeing here is compaction that occurred even when deep ripping took place. All right, so what does that mean in terms of the ability to get water from rainfall into the soil? So the undisturbed environment is set back away from where the pipelines were set in. And the disturbed area is in that zone where the pipe was laid, but also in the adjacent area where the heavy equipment traffic occurred. And what you're seeing here is in 2020, they measured the amount of soil water. It's called gravimetric soil water because they take soil samples, they weigh them, and then they dry them in an oven, and they look at how much water evaporated when they dried it, and they can calculate the water content, the gravimetric water content of the soil. And you can see in that disturbed zone, those lines with the dashes are lower than the undisturbed zones. Why is that? It's because less rainfall was able to penetrate into the disturbed soil because it was more compact. They had pressed out all the pore space, and it was more difficult for water that fell on the soil surface to make it down into the soil. And that's important because if you have roots looking for water during a droughty portion of the summer, if they don't find it, crop yield goes down. And where you have more water, the lines are higher in the undisturbed graph on the left than on the disturbed graph on the right. Where you have more water, the crop is likely to do better. So here you can see the corn crop in the disturbed and undisturbed areas, right? So that's looking across the field. The pipeline would be running from where I'm sitting into the screen. And you can see on the disturbed section of the field, the corn is considerably shorter. And you can see that graph on the right, the corn height in millimeters is a lot lower for the disturbed zone than for the undisturbed zone. And that again corresponds to where the field soil was compacted by the use of the machinery to construct the pipeline. And this occurred, this was published in the journal Soil and Tillage Research, and it's a scientific article that came out in 2022. Again, put together by a set of agronomists, soil scientists, and ag engineers at Iowa State University. All right, so construction took place in 2016, and then starting in 2017, they grew a soy corn rotation on the field. And again, they had zones of the field that were undisturbed by construction traffic, and they can compare those areas with zones in the field that were subjected to field traffic and compaction. And you can see that the yields of both soy and corn were 15 to 30% lower in 2017 through 2020 in the disturbed areas of the field relative to the undisturbed areas. So there's a yield penalty that occurs 4 years, 5 years after the construction took place. And when I looked through the scientific literature, it's clear that soil compaction due to pipeline construction has been studied throughout the world, and that subsoil compaction is very difficult to relieve, even with deep ripping, and that the effects on crop yield continue for many years. Now, how many years the Dakota Access Pipeline will affect crop yields in those fields, I can't tell you. But for construction in 2016, the effects were still evident quite strongly in 2020. All right, here's another thing to consider. Central Iowa is heavily tiled, and the last estimates I've seen for pattern tiled fields indicate that the cost might be on the order of $700 to $1,000 an acre to put in relatively close spaced tiles, like you can see on the leftmost side of the screen. Areas that have somewhat restricted drainage can be tiled to improve crop yields. And that's an expense that a landowner takes on as an investment for the value of that land on into the future. Well, if a pipeline goes through a field and crosses where those tile lines are, obviously the tile line is going to be disrupted because the pipeline will be set deeper than the tile. So to lay the carbon dioxide pipeline or an oil pipeline, you have to break the tile for water movement. And that requires the repair of each individual tile line if the field isn't going to have flooded portions after the carbon dioxide pipeline would be built. So this is a diagram filed by a firm that intends to remediate the damage to farm owners' tile lines due to the construction of the Summit Carbon Solutions pipeline. And they have this idea that they're going to break the lines temporarily and then implement the carbon dioxide pipeline and then patch in a section of pipe to support the continued flow of water in the tile lines. So every time they're going to cross a tile line with the carbon dioxide pipeline, they have to do this. And it's not a trivial task, right? It has to be done correctly. If there's subsidence of the tile line, you'll get potentially it can crack and you won't get water flowing in the direction that you want. It may pond in the field. So Iowa farmland now, corn and soybean land in the 2022 land survey is now worth on average more than $11,000 an acre, in part because people have put a lot of tile in at a cost of $700 to $1,000 in recent years. So these big investments are going to be potentially impacted by the construction of carbon dioxide pipelines. All right, just a couple of other things to keep in mind. Carbon dioxide emissions from the United States are in the order of 4.7 billion metric tons per year. Agriculture contributes about 11% of that. Transportation is the big sector, adding greenhouse gases. Methane, nitrous oxide, and fluorinated gases are all contributing to the greenhouse gas load. When you do that in terms of carbon dioxide equivalents, that adds up to about 6 billion metric tons per year coming out of the United States. If we look at Iowa, we have a lower population. We're an agricultural state, and most of our emissions are coming from agriculture, but our total emissions are a small fraction of the US total. We contribute about 77 million metric tons of CO2 directly, and if you add in the nitrous oxide, methane, and other greenhouse gases, that comes out to about 121 million metric tons. All right, so the idea about these greenhouse gas measurements is I wanted to compare what these carbon dioxide pipelines in Iowa are intending to transport relative to the emissions of carbon dioxide, which we're trying to cut back on in the United States. So let's compare some numbers. In the United States, we produce about 15 billion gallons of ethanol per year. And Iowa produces roughly 30% of the ethanol produced in the United States. Producing 15 billion gallons of ethanol would provide the opportunity to capture 43 million metric tons of carbon dioxide during the fermentation process in an ethanol plant. So the big attraction for carbon dioxide pipelines and ethanol plants is the fermentation process generates almost pure CO2. And that can be taken out of the ethanol plant and could be put in a carbon dioxide pipeline. It would be 99+% pure. So if a private entity like Summit or Wolf or Navigator could get paid a lot of money for carbon dioxide, a carbon dioxide output from an ethanol plant would be ideal because you can get almost pure carbon dioxide. But what does that 43 million metric tons of carbon dioxide produced in the United States mean relative to total US carbon dioxide emissions? So it's about 2.3% of the carbon dioxide emissions from the transportation sector and about 1% of the annual carbon dioxide emissions for the United States as a whole. So even if we caught every molecule out of every ethanol plant in the United States, it would sequester only about 1% of the carbon dioxide emissions from the United States. As I mentioned before, Iowa produces about 30% of the ethanol in the US, and we could capture about 12.8 million metric tons of carbon dioxide at Iowa ethanol plants. And that corresponds to 0.8% of the national transportation carbon dioxide emissions and 0.3% of our nation's total carbon dioxide emissions. So what Iowa ethanol plants could contribute to carbon capture would be a tiny fraction of total carbon dioxide emissions in the United States. I'm not saying that that's a bad thing to do, but we have to weigh it against the costs incurred by individual landowners and farmers to crop productivity and long-term soil health. So the question that you all are grappling with is this one of eminent domain. Eminent domain allows private land to be taken for fair compensation And it's intended for projects that serve substantial public interest. So the question is, when you look at the amount of carbon dioxide that might be captured from these ethanol plants and transported across Iowa farmland, does carbon dioxide pipeline construction exceed? Does the benefit from those carbon dioxide pipelines exceed the damage to farmland and crops? So those are individual farmland owners who are going to bear those costs. There might be some compensation, but you have to ask yourself, how long will that damage exist? So I'm going to stop there and open it up for questions. And again, I'm not speaking for Iowa State University. I'm just relaying to you published scientific literature that has been developed by colleagues